Hi guys, welcome to today's tutorial. I'm going to go through the 2020 Level 2 Organic Chemistry exam. Give it a thumbs up if you enjoyed the content. Really help the channel grow. So let's get going. So first question, as always, is going to be this type of naming and drawing question. So butane 2amine. So start with but. But means 4. Amine means you have nitrogen, 2 means you have a nitrogen on the second carbon. Just make sure every single carbon has 4 bonds and every nitrogen has 3 bonds. Okay, so we can do the H's the next part. This is the 5, so this is pent. I know I have an OH group, so this is alcohol, so it's something OL. Where is the OL? Where's the OH? The OH is on the second carbon, so it's pentan 2O. So you start counting from the side that will give the functional group the lowest number possible. All right, next one. So we have an alkene. So we have 1, 2, 3, 4, 5, 6 carbons. So this is hex 2ene because hex 2ene gives me the lowest number possible. So that means this CH3 here is going to be 2-methyl hex 2ene. Ethane, just this is ethane. Iodo means on one of the carbons I have an iodine. Okay, nice and easy. And next one, identify the alcohol in the table above as primary, secondary, tertiary, or tertiary. So we are looking at this. So this is the alcohol, so that's going to be a secondary alcohol. I'll just draw it here so that we can see the reason why this is a secondary alcohol, because the OH group is bonding to a carbon that is bonding to 2 other carbons, so that's why it is a secondary alcohol. Okay, so moving on, next one. Depending upon the conditions which is used, sulfuric acid, which can enable the 2 reaction to occur. So we're going from alcohol to alkane, alkane to alcohol, very standard. In the boxes below, draw the structure formula for a molecule containing 2 carbon atoms that could be used in the reactions above. Okay, so that just means 2 carbons. It has 2 carbons. Let's use a black one. So for example, I can turn 2 carbons alkene. So this is ethane, and I can turn that into a ethanol. Okay, well, ethanol is more correct. And elaborate also how sulfuric acid is used in the conversion to make an alkane and alkane to make an alcohol. So this is where you just have to know your reaction. So you need to know if you're going from alkene to alcohol, you are using diluted H2SO4. Okay, so for example, if you're going from this alkane to diluted H2SO4 to become the alcohol, what happens here is that you break the double bond, then you add an H to one of the carbons, you add an OH to the other carbon that were originally double bonded. Okay, so this is addition reaction. Addition reaction means that you break the double bond, you've broken the double bond, then you added the water, which is a diluted part. You added the water on the 2 carbons before, okay, that were double bonded before. And if you're doing an elimination reaction, I'm doing this in red. Actually, let's do it this way so you can see. Okay, let's say this is my ethane 1O, so I deliberately draw it so you can see. Elimination reaction is when you use concentrated H2SO4. You delete the OH has to go, and then you remove a hydrogen from the neighboring carbon. So the only 2 carbons here, so you just take one of the hydrogens from the neighboring carbon, then you form alkene. Okay, so this is just a test of your flow chart, just so you remember that if you going from diluted to concentrated, if you're going alkene to alcohol, you add diluted H2SO4, and if you're going the other way around, you add concentrated H2SO4. Okay, very straightforward. All right, now look at the flow chart. So the flow chart question is, like always, a guaranteed excellence question. So getting this fully correct, means you get 1 excellence point. Okay, so this looks like a very easy process. So let's start with this. The minor product. Okay, let's get rid of that so we can see. Okay, so the minor product, let's use the black one. So let's just go through the flowchart. I mean, I can just give you the answers, but that's not why you're here. You want to hear the explanation. So if I add HCl, now the thing when I tell my guys how to do this, people in my class that I teach at my school, I tell them just to copy paste what they see. But then when you do an addition reaction, because that's all alkane do. Alkane in level 2, you only know the 2 types of reactions that you see alkanes undergo addition reactions and oxidation reactions. Okay, so oxidation reactions is when you see like potassium permanganate or dichromate, which really stand out. So if you see something like HCl or water, you know, like the diluted H2SO4 in the previous example, these are all addition reactions. Okay, so when I do addition reactions, I tell my guys just to copy it down, but get rid of the double bond, and then you can put the H here, you can put the Cl here, or you can put the Cl here and put the H here. Because the alkane is asymmetrical, then you can have a choice. Okay, so because you make 2 different molecules. Now which one's major, which one's minor? So we are adding stuff, so rich gets richer, so that means the carbon. So if you look at these carbons here, this carbon here that originally has 2 hydrogens is more likely going to pick up another hydrogen. Okay, so this is going to be the one I highlighted is going to be the major product, and then this is the minor product. Okay, so we can just copy this one through. I mean, you can look at Long Lindsay QA answers. They're not going to tell you why this is the right answer, and then you know it's not very helpful. If we look at this part, I mean, we can go different pathways. Now let's just go follow this way. So if we adding NH3 alk, that means you are simply substituting, you are simply exchanging the Cl with the nitrogen, which in this case will be CH2, NH2. Okay, so because nitrogen, remember nitrogen only bond 3 times. Okay, let's go this way. You can see you're doing this right. Can you guys see the OH group is on this carbon, and see my Cl group is on the same carbon? That means you've been doing something right, because it's not the carbons that changes, it's the functional groups, and the position of the functional group doesn't really change unless you're doing an elimination reaction in year 12 anyway. That might, you know, move it around a little bit, but all the other reactions you should see the functional groups on the same carbon. Okay, so this is the same thing, substitution reaction. How do I do this? So this is where you use KOHAQ. You can use sodium hydroxide AQ as well. KOHAQ is the one I tend to use, and then from here you turn. Alright, so this is an oxidation reaction. Now how do I know that? Because you turned your alcohol into a carboxylic acid. So you could use MnO4- /H plus, or you could use Cr2O72- /H plus. It's a personal choice, just pick one and go with it. Okay, and then you have a carboxylic acid, and this is sodium hydroxide. It's a base. Acid plus base is a neutralization reaction. That means when you neutralize something, so hopefully by the time you're watching this you would have done 2.6, and you will understand that when an acid react, it donates the hydrogen, so which is one I highlighted. So that's why it's a carbon. So in carboxylic acid, this is the functional group, and as an acid it will donate the H away, so that's why it forms the propanoid ion. Okay, moving on to the next question, question 2. So this is a addition polymerization question, so this is Teflon. Let's just answer this. Draw, name the structure of the monomer. This is so easy, just cut it on the every second carbon and just copy paste. This is again what I tell my guys to do. Identify the part that is you know, that is being repeated, copy it and double bond it. Okay, and what do we want to do? Name it. Oh, that's rather That's rather difficult. Well, it's not difficult, just annoying. So you have an ethene, okay, and then because ethane means a CC double bond, and you have 1, 2, 3, 4. So you have 1, 1, 2, 2 tetrafluoroethane. That's quite nasty for a merit achieve this type of question. Tetra means you got 4, and I got 4 fluorines. Where are they? On the first, on the second carbon. I mean, if you said tetrafluoroethane, no one's gonna mark you wrong, because that's 1, 1, 2, 2 are the only possible positions. Okay, but I'll just put it there just in case you are wondering why they'll have those numbers. Now, the chemical reactivity of the monomer and the polymer are different. Analyze the differences. In your answer, you should link the structure of the monomer and polymer to its reactivity and explain the importance of this difference. Okay, so you need to remember that why monomers are quite reactive. Okay, so monomers, because they have a double carbon-carbon double bond, that means they're more reactive. Okay, so that's why they can undergo the addition reaction. But then polymers is a result of when you have all of these guys just single bonded, so this is less reactive. So if you want something that's involved in cooking, for example, you don't want the material that you're using to cook to react with the food that you're making and then later on consuming. Okay, because you remember you're cooking stuff, and when you're cooking stuff, you're gonna involve quite a bit of heat. So you don't want your polymer, that whatever you're using, to react and turn into something else. And when it reacts with heat, and then it goes into your food, and then you eat it, and then you're gonna have a really rough few days due to food poisoning. Okay, so that's pretty much all there is. I think I got the answers here. So yeah, so each monomer contains a reactive double bond. So the double bond is more reactive, the other one is not as reactive. So when you're cooking, it won't react with any food. Okay, so you know, just common sense really. But I quite like this question because you know, it actually gets you to think about what we're learning here. All right, next one. So butane can. This is such a horrible way. I mean, you should have said this is butanene because they're butying. Oh wait, they've done it for the 3 isomers. Never mind, I was being too critical. Okay, so they got 3 isomers of butane. So circle the form of isomerism that exists between A and B. So A and B are geometric isomers, and C are A and B are, jump the gun a bit. A and B are constitutional structure isomers, and C is and B and C are geometric isomers. Okay, so the reason for that is that you look at A. Now remember, for what is, just to clarify, what are geometric isomers? The easier way that I remind my students as this, I just say the cis and trans isomers. And the reason for any cis and trans isomers to occur, you must have a CC double bond to prevent rotation, which all of them do in A, B, and C. But then the other thing is that the 2 groups bonding to each of these carbons, so this bit's here, this bit's here, these 2 must be different, and these 2 must be different. So the 2 groups bonding to each of the 2 carbons, bonding to each of the carbons in the carbon-carbon double bond must be different. And if they aren't different, they don't exist as cis and trans or geometric isomers. So that's why if you look at A, can you guys, you can see the CH2 double bond C, so I don't even need to do the rest. So that means this carbon is double bonded with the other carbon, but then it has 2 hydrogens. So that means it doesn't, so this is rule number 1, this is rule number 2, it doesn't follow rule number 2, so that's why it doesn't have geometric isomers. And then for B and C, these 2 will have geometric isomers. This is cis, this is trans. Cis means it's on the same side, you can draw a letter C, trans is on the opposite side, and that's what you can talk about there. Okay, so it's about wording. As you can see, it's quite a bit of wording. I just got this from the NCEA website. But then you can see, you know, one is butene, one is butene, blah blah blah. Now this is key here. To form geometric isomers, you must have a double bond, and then the groups of atoms bonding to each of the carbons on the double bond must be different. Memorize that, the bit that I just highlighted. Memorize it, go into the exam, write it down. Okay, and then you can just apply to the question. So the double bond, what it means, it prevents rotation to occur around the double bond, and if the CH3 groups on the same side, it's cis. If they're on the opposite side, it's trans. And molecule A is not a geometric isomer because simply the atoms on the first carbon, which are the two hydrogens, are the same atoms. Okay, so that's the longest one. That's the thing I like about organics. It's just really, I don't know, it feels really rewarding. I think if you know what you're doing, it's going to be incredibly straightforward. Same as level 3 organic. If you didn't do so well in level 2, you will struggle in level 3 because they're going to be about 20 to 30% of the content that still be relevant to year 12. So it really pays to do well this year. Okay, let's look at question number 3. So question number 3, major minor products. Yes, of course. 1,3-methyl-2-chlorobutane. We have with KOH alk. So when you see KOH alk, and just as a reminder, this means you make elimination. Okay, and then in the previous question, I think it's question 1, when you see KOH8Q, this is when you have substitution. And then I always use this example to remind my students, you know, which one's which, because it literally the only thing different is one is alcoholic condition, one is aqueous condition. How do you remember which one's which? And just, you know, tell yourself alcohol, you know, in alcoholic conditions, people that consume alcohol tend to get drunk, and when they get drunk they lose stuff, so elimination. Aqueous is that when you drink water and then you have to go to the bathroom to replace the body fluid, you know, and then that substitute your body fluid. Okay, so that's one way to remember it. It works for me, so hopefully that might work for you. Okay, so for this particular reaction, just remember the Cl has to go because that's a function group, and then we have a choice. We can either take away this hydrogen or we can take away this hydrogen. So if we number it's 1, 2, 3, 4. Now carbon number 1 has 3 hydrogens, carbon number 3 has 1 hydrogen. Poorer gets poorer, it's more likely that we will take away the hydrogen from the third carbon rather than the first carbon. Okay, so that's why it's just more stable that way, you know, just easier to get rid of it. Okay, so state the type of reaction, so it's elimination, and why two products form. Now in your answer, so just bring it up here, in your answer please avoid using the rich gets richer, poor gets poorer statement. That's not scientific. That's simply what a lot of us or a lot of teachers say to you guys just to make you remember it, because that's common sense. Okay, so elimination reaction. What's the elimination reaction? Because you form a double bond, you remove a chlorine and the neighboring hydrogen atoms, and then why do you form two products? Because there are two possibilities where you can remove the hydrogen. Okay, so one is a major, one is a minor. So the major product is identified by the carbon losing the H from the carbon that's already got the least amount of hydrogen atoms, so which is the carbon number 3. As you can see, I prefer numbering it, okay, because I don't want to say this is the carbon to the right. I just say this is from carbon number 3. Refer to my diagram, okay, which compared to carbon number compared to the carbon number 1 on the left. What do they do here? So it's more likely carbon number 1. What did I mean, carbon number 1? Okay. So this is a really good example that you can't trust NCQ's answers. Okay, so because we know for sure carbon number 3 is more likely to lose another hydrogen atoms. Okay, as it has 1 hydrogen compare, yeah, okay, so I made a typo in the answers. Okay, so carbon number 3 is more likely to lose another hydrogen atoms, which is 1, 2, oops, why am I using the highlighting function here? 1, 2, 3, 4. Carbon number 3 is more likely 1, 2, 3, 4. So this carbon number 3 is more likely to lose H. Okay, so there you go. You can take a screenshot of that, but just remember, we don't want to see rich gets richer, poor gets poor. Okay, just get used to the wording. Just you want to explain that it's more likely for the carbon with the least number of hydrogen, but remember it has to be the neighboring carbon of the chlorine. It can't just be going down to the end of the carbon chain and find a random carbon that has the least number of hydrogens. It has to be the neighboring ones. It's either on the left or on the right. Okay. All right. Now this must be distinguishing test. Yes, it is. Okay. So we know that we have ethanol, hexane, and propanoic acid. And please, whoever wrote this exam, I know it doesn't matter. Hexane. There are 3 different ways of drawing hexane. There's hex 1 in, hex 2 in, hex 3 in, and obviously these whoever wrote this is a bit slack. Okay, but it doesn't matter, I don't think. So we're allowed to use sodium hydrogen carbonate, and that's all we are going to use. Okay, all right. So you're only allowed to use one thing. All right. The easiest way to use this particular thing. Now just be mindful, this is a solution, this is aqueous. Aqueous means is dissolved in water. Okay, so just as a hint, a solution, aqueous, this means this is HCO3 is dissolved in water. Okay, so water is a polar solvent. Ethanol is polar, hexane is non-polar, so straight away you can just pour that into the thing. You can just pour, you can state any observation. So you can do this multiple ways. When I see it first, I just know for a fact, because of the difference in polarity, I will put this NaHCO3, I'll put that in ethanol. Then what I'll see one layer, because they will mix, they will dissolve, because these two are soluble in each other. If I put this in hexane, there will be 2 layers. Okay, because this is non-polar, this is polar, and they won't dissolve. All right, so they can easily be distinguished. And then for your propanoic acid, same thing. Propanoic acid, I'll just put this in there, and then what you will see, because one is a carbonate, one is an acid. Acid plus carbonate gives you bubbles. Okay, so what happens here is that you have CH3CH2COOH reacting with NaHCO3. Acid plus carbonate gives you salt. Salt, COONA plus CaO2 plus water. Okay, and that's it. All right, let's have a look at the answers. Or if you can't see the this thing here being an aqueous solution, if you didn't understand that, you should be able to understand that your propanoic acid is also a polar solvent. You know, it's polar. So if you can't see putting sodium hydrogen carbonate into the liquid, just put the propanoic acid. Once you identify that, because that's the only one that bubbles, put that in there. Then with the ethanol, you'll see 1 layer. With the hexane, you'll see 2 layers. Same outcome. Okay. So here's C thing. So this, they're saying it can be distinguished because it's so soluble, whereas the other one you would be insoluble. Okay, so propanoic acid bubbles of CO2. Okay, and then you have the equation there. Very easy. Now if you do struggle with the, just remember acid plus carbonate gives you salt, CO2, and water. And you can just use something that you learned from level 1, like say for example, if you don't like using this, why don't you just do this? just replace the HCl, sorry, the CH3CH2COOH, and then you should be able to do this. Then you have NaCl plus CO2 plus H2O. Okay, can you guys see that the H have left? So that's the same thing. You remove this H and then you put the Na. Can you see the Na from the sodium carbonate? Can you see the Na from sodium carbonate? So all you do is just combine the two together. Okay, it's exactly the same reaction, exactly the same thought process. You just need to do a little bit of copying pasting, as I tend to call them. Okay, now explain how you could use an alternative test that will allow you to distinguish between hexane or propanoic acid. Okay, so there are quite a few options because you've got a carboxylic acid and you got hexane. All right, now my personal favorite is use bromine water. There are quite a few that you can do. Bromine water, when you react with hexane, that will go from orange to colorless straight away because you are undergoing a addition reaction, and this guy with the propanoic acid, that won't react. Okay, you can do hexane, you can use potassium permanganate acidified, and be mindful you do not use dichromate. Okay, dichromate is actually not a great well, it's a bit of it's stronger than your permanganate, and then that will cause a bit of problem because it will tend to oxidize and tend to break down a lot of the molecules. So you have to remember, if you're going with alkenes, it has to be potassium permanganate. It doesn't have to be acidified. If it's acidified, what you will see is that you'll see the permanganate going from purple to colorless, and when you do react with this guy, nothing happens. Okay, another thing that you could do is use now you have to be very careful. They have specifically highlighted chemical test. Chemical test, that means litmus paper and universal indicator are not allowed because it is not a chemical reaction. It is not a chemical test. So you could use what you did in last year, which is acid plus metal. So you can react this with zinc, you can react this with magnesium, you can react it with aluminium, but the reaction in reality is going to be really, really slow, but you can still see hydrogen bubbles. Okay, now if you are so those are my common three, but I feel this I feel this they deliberately put the carboxylic acid here to trick people, because a lot of year 12s last year would have, I think, would have gone with the litmus paper, because they would have just, oh, that's an easy one, easy merit excellence, just go with the litmus paper, but then you would have got nothing. Okay, because that's not a chemical test. Bromine water will be your safest way. Whenever you see alkenes or alkanes, go with your bromine water. Whenever you see proper carboxylic acid, go with your carbonate, or you know, or go with the metal, but that's not the best one. Okay, those are your safest way to go. All right, so let's have a look at the answers. So the answers, so there you go. You got you got bromine water. Bromine water, you go from orange to colorless. Well, where's my bromine? There you go. Bromine will change from orange to colorless. This is addition reaction, whereas the other one doesn't really react. Okay, acidified potassium permanganate, so you know, protein will go from purple to colorless. If you use non-acidified, you'll go from purple to brown. There you go, purple to brown. And here it is, not litmus paper, so I was right. So you don't use a litmus paper. Okay, it's not a chemical test. Okay, so hopefully that has been useful. So that's the end of the exam. Very, very straightforward, no surprises here. Okay, so I hope this video has been somewhat helpful, but like always, leave a like if it helped you, and it really helps the channel to grow and beat the YouTube algorithm. Okay, so like always, good luck with your studies, and I'll see you guys next time. Bye bye.